Okay, hey everyone. This is Connor Mead with the Calculation Center, and here we're going to be going over solving some systems of linear equations. Okay, so this thing here is what we'd call a system of linear equations. It's an equation in three variables, and it's a system of three equations. Okay, so it's a three variables, three equations. This generally means we expect one solution. It's not always the case, but it's kind of what we expect. Okay, so generally speaking, when you've got a system of linear equations like this, you want to add and multiply these rows together to try and get a single solution, or rather to reduce it into a simpler set of equations. Now, how do we do this? Generally speaking, once you get more than two equations, the easiest way of going about this is writing this as an augmented matrix equation. Okay, to do that, all you do is you keep track of each of the coefficients. So you write down the coefficients of the x variable in the first column. So let's say we've got here 2x, 3x, and 2x. So we write down a 2, 3, and 2. Okay? In the next column, we're going to keep track of the y's. So here we got a 3y, a 1y, and a 4y. So this becomes 3, 1, 4. And last column, we're going to keep track of the z's, as you might expect. And we get minus 1, 8, 2. Okay? Now, what this, if we put in a bracket here, this would be a matrix. But to make this an augmented matrix equation, what we do is we draw a short straight line here and write down the constants on the other side, right? So the things that this is equal to. So this is equal to 8, minus 1, and 6. And this is what we'd call the augmented matrix form, or the augmented matrix equation, perhaps, of this system of linear equations. Now, from here, the aim is going to be to try and reduce this to have this look like, we want to somehow get this to look like 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, and then some numbers over here. And then what will turn out is this will be the value of x that satisfies the equation, this will be the value of y that satisfies the equation, this will be the value of z that satisfies the equation. Okay, so that's kind of what we want to do. Now, how do we reduce it to this form? We're allowed to do three things. We're allowed swap rows, we're allowed multiply rows by constant numbers, so we could multiply all the top row by 3, for example, and we can add rows together. Okay, and we want to use these three techniques to somehow turn a lot of these numbers into zeros, basically, and be only left with ones along the diagonal. Okay, now how are we going to do that? Well, we're going to do a thing called the pivot method. Now, the pivot method, you put a box around the top left entry. This is assuming the thing inside the box is not 0. If it is 0, you have to do something slightly different. So you have to swap some rows to be clever and avoid that situation. But in this example, that won't happen. So let's just go through it as we'd expect. So the idea here is that you want to use the thing inside the box to turn everything below it into zeros. Okay? To do this, we're going to basically find common multiples between the coefficients here. So this is a 2, this is a 3, this is a 2. So I could, if I multiply the top row by 3, the middle row by 2, and the last row by 3, we'd turn them all into 0. We'd turn them all into 6s, and then we could subtract them off of each other to turn them into zeros would be our idea. Okay? So we're going to do that. We're going to send row 1 to 3 row 1, row 2 to 2 row 2, and row 3 to 3 row 3. The reason we're doing these specific numbers is because, remember, we want to turn this leading coefficient into a 6. So row 1 has to get multiplied by 6, this has to be multiplied by 2, this has to be multiplied by 3. So you get 6, 9, minus 3. Because remember, when we multiply row 1 by 3, you have to multiply the entire row. So we get something like this. Here we're going to multiply the row by 2, so we get something like 6, 2, 16, minus 2. 6, 12, 6, 18. Okay. From here, we're going to want to subtract. Remember, we can add and subtract rows. So what we're going to do here is we're going to send row 2 to row 2 minus row 1, and row 3 to row 3 minus row 1. And that will turn these 6s into zeros, because 6 minus 6 is 0. 6, 9 is minus 6, 9 minus 3, 24. This doesn't change by our operations this time. These will become zeros. And we just look at the differences here. Minus 7, because 2 minus 9 is minus 7. 16 minus minus 3 is 19, because minus is turned into a positive. 3 and 9. And we also have to subtract over here, so there'll be a minus 26. And this will be minus 6. Okay? Now, So notice that we've turned all the things below our pivot into a 0. So now we go on and put our next pivot. To get our next pivot, we go down 1 and to the right. So this -7 is now our pivot, is our next pivot, I should say. From here, we're going to want to, again, find common denominator, because we're going to want to use this pivot again to turn this into a 0. To do that, we send row 2 to 3 times row 2, and row 3 to 7 times row 3. This is going to get us -21 here and a 21 here, and then we can just add those numbers together to turn this third row second entry into a 0. Okay, so by the thing we're doing this line, it won't change the top row, so we'll just write that down. And this middle row will be multiplied by 3, so 0 minus 21, 57, minus 26 times 3 is -78. 0, 21, 27. Oh, sorry, not 27. So it's 7 times 9, that's just 63. And -6 times 7 is -42. Okay. And now we're just going to add, so we're going to send row 3 to row 2 plus row 3. So this becomes 6, and sorry, our pivots here are here and here. And remember, we want to turn this 21 into a 0 using this pivot box. 6, 9. It's important that you use the pivots and not like other equations. Don't try and use this equation up top to turn this into a 0. You want to use your latest pivot, basically. This also won't change. 57 minus 78. And this becomes 0, 0. So we're adding these together. So this becomes 110, I believe. Is that right? No, it's 120, excuse me. Yep. And this becomes a minus 120. Okay. And now notice that we've got all our pivots. We've got a pivot here. We've got a pivot here. And now all the entries below this pivot are 0. So we move on and put in our next pivot, which would be this one, because we go down to the right. But now we can't put in any more pivots, and there's no zeros below this, so we're done. So what do we do now? Up to here, this was called forward elimination or Gaussian elimination, depending on what you call it. So what we need to do here is, at this point, basically, we're going to try and tidy up a little bit, I would say. And what this comes down to is, well, we can turn this into a 1, basically, right? Because we can divide across by 120 across this line. So this becomes 0, 0, 1, minus 1, right? Once we divide across by 120. We'll leave everything else as it is for now, because this is a particularly easy one to do. 9 minus 3, 57. So a lot of these numbers look pretty unpleasant to work with. But because this last equation basically says z is equal to -1, I say this last equation, it's the last row, which can be interpreted as an equation. It basically means by subtracting off copies of this row, we'll be able to turn the things above it into 0. Sorry, this is a 6, not a 0, of course. So to do this, we're going to send basically row 2 in this step. Row 2 is going to send to row 2 minus 57 times row 3. Because now the game is to turn the things above the pivot into 0, right? And if we subtract off 57 copies of row 3 here, we won't change anything over here because these are zeros. But we'll turn this 57 into a 0, which is nice. And we're going to send row 1 to row 1 plus 3 row 3. Because this one, if we add on 3 to this minus 3, we'll get 0. So this becomes 6, 9, 0, 0, minus 21, 0, 0, 0, 1, minus 1. And the important thing is we have to be careful here. So we subtracted off 57 times row 3. So that means we're adding 57 minus. So we're subtracting off 57 times minus 1, which is the same thing as adding 57. And I think that'll get us 21, or minus 21, I should say. Right? So it's 57 plus minus 78 is minus 21. And up here we're subtracting off 3, so this just becomes plus 21. Okay? Now, at this point, notice that everything above and below this pivot is 0. So we're done with it, and now we go back to our next pivot, or our previous pivot maybe. So the idea is first we work down like this, getting our pivots. and then we start working back up. This is kind of the action that you should be imagining as we're going through this process. So just dividing, oh, I should clarify this step up here. This one here, I didn't write in the step here because it was kind of simple, but this is row 3 getting sent to row 3 divided by 120. Similarly, we're going to send row 2 here to row 2 divided by 21, or minus 21, I suppose. So this gets us 6, 9, 0, 0, 1, 0, 0, 0, 1, minus 1, 1, and this is still 21. Okay, so we divided across by minus 21, and we got, we basically cancelled, right? Minus 21 divided by minus 21 is 1. Okay, and lastly, we just, to complete this, basically, we just now need to get rid of this 9 and turn whatever's left over here into a 1. So this becomes row 1 gets sent to row 1 minus 9 row 2, and that will turn this 9 into a 0, right? So we get 6, 0, 0, 12, 0, 1, 0, 0, 0, 1. Okay? And this is 12, 1, minus 1. And dividing across by 6 on this top line, so sending row 1 to row 1 over 6, we get 1, 0, 0, 0, 1, 0, 0, 0, 1 is equal to 2, 1, minus 1. And at the start I said this is a signal to say we're done with this equation because we can't basically do any more on this left-hand side. So now we just read off our solution. It says that x is equal to 2, the first entry up here, y is equal to 1, second entry over here, and z is equal to minus 1. And this is our solution to our initial system of linear equations. And if we were to substitute back into the initial equation, we'd get these solutions. Okay, so this is Connor Mead with the Calculation Center, signing off.